Dear students, today we are going to discuss about Unit 19 Test of Significance. 19.0 Objective Structure, 19.0 Objective, 19.1 Introduction, 19.2 Test of Significance for small sample, 19.3 T-test for single mean, 19.4 Difference of mean, 19.5 Summary, 19.6 Keywords. What is objective? 19.0. When conducting a significant test, the goal is provide evidence to reject the null hypothesis. If the evidence is strong enough to reject the null hypothesis, then the alternative hypothesis can automatically be accepted. Introduction. In statistics, test of significance or the method of reaching a conclusion to reject or support the claim based on sample data. That statistics are a special branch of mathematics which deals with the collection and calculation over numerical data. This subject is well known for research based on statistical surveys during a statistical process. A very common as well as an important term we come across is significant. In statistics, it is important to know if the result of an experiment is significant enough or not. In order to measure the significance, there are some predefined tests which could be applied. These tests are called the test of significance or simply the significance test. 19.2 Test of significance for small sample. Null hypothesis H0. The hypothesis tested for possible rejection under the assumption that is true is usually called the null hypothesis. The null hypothesis is a hypothesis which reflects no change or no difference. It is usually denoted by H0. Alternative hypothesis H1. The alternative hypothesis, the statement which reflect the situation anticipated to be correct. If the null hypothesis is wrong, it is usually denoted by H1. Level of significance. It is the probability level below which is the null hypothesis rejected. Generally 5% and 1% level of significance are used. Critical region or region of rejection. The critical region of a test of statistical hypothesis is that the region of the normal curve which correspond to the rejection of null hypothesis. The shaded portion, the following figure is the critical region which correspond to 5% line of significance. The sample value of the statistical beyond with the null hypothesis will be rejected or called the critical value or significant value. This level of significant types of test and then 1% level, 5% level, 10% level. This is a two-tailed test, one-tailed test. What is type 1 and type 2 error? What is type 1 and type 2 error? Type 1 error, a rejection of null hypothesis when it is correct. Type 2 error, acceptance of the null hypothesis when it is wrong. Test for significance for single standard deviation. Formula for test statistics is equal to S minus sigma whole divided by sigma divided by square root of n, where S is the standard deviation from the population. Test of significance for quality of standard deviation of two normal populations. Formula for the Z test S1 minus S2 whole divided by square root of sigma 1 square divided by 2n1 plus square root of sigma 2 whole square divided by 2n2. Test for equally standard deviation of two normal population. for Z test Z equal to this. Example, a number of electric bulbs by some process find the standard deviation of lamp to be 10 hours. We want to change the process. If the new process result in even smaller variation in the life of lamp, in adopting the new process, a sample of 150 bulbs gave the standard deviation of 95 hours. If the manufacturers justified the changes the process, solution given standard deviation 100 and S equal to 95, N equal to 150. The parameter of interest is sigma. Here, the null hypothesis this H naught equal to null hypothesis sigma equal to S. There is no significant in the change of process. Alternative hypothesis, there is a significant change in the process. Again, alpha values at 5% level of significance, the test statistics is that equal to S minus sigma all divided by sigma divided by square root of n. This reject null hypothesis mean if the modulus of Z is greater than 1.96 at 5% level of significance. By using the given data, apply the value Z equal to minus 0.866 or taking modulus on both sides, modulus of Z equal 0.86. 0.86 is less than the tabulated values of at 5% level. So the null hypothesis H0 is accepted at 5% level of significance. So the manufacturer find no justification changes the process on the evidence alone. And then random sample drawn from the two countries gave the following data relating to the heights of adult male. This country A, B, this mean height 67.42 and country B 67.25. Standard deviation for country A 2.58, standard deviation for B 2.50, number of sample in A 1000, number of sample in B 1200 if the difference between the standard deviation significant. As for the given data, apply the formula that is we calculate the values of Z equal to 1.03. Conclusion modulus of Z equal to 1.03. Therefore, Z equal to 1.03 is less than 1.96. So we accept the null hypothesis H0. There is no significant difference between the data of the two countries A and B. If the sample standard deviations not differ significantly. This example 3, the standard deviation of weight of all standard in a first grade of college was found to be 4 kg. Two samples are drawn. The standard deviation of the weight of 1,100 undergraduate student is 35 3.5 kgs and 50 postgraduate student 3 kgs. Test the significance of the different standard deviation of the sample at 5% level. As for the given data, this null hypothesis H0, there is no significant difference between the two data. Alternative hypothesis assume that there is a significant difference. Just apply the formula. The calculated value is Z equal to 1.02. 1.02 less than 1.96. Therefore, we accept the null hypothesis H0 at 5% level of significance. Therefore, there is no significant difference in standard deviation. T-test for single mean. T-test mean if the sample size less than 30, the sample is small sample. We apply the small sample. T-test T equal x bar minus mu s divided by square root of n or x bar minus mu divided by standard deviation whole divided by n minus 1 where s square equal to n divided by n minus 1 sigma square, that is sigma equal to standard deviation. A sample of 10 house owners drawn and the following values of their income are obtained mean rupees 6,000, standard deviation rupees 650. Test the hypothesis. The average income of the house owners of the town is rupees 5,500. As for the given data, the sample size is n equal to 10. 10 is less than 30, so we apply t-test for single mean. The null hypothesis H0 mu equal 5,500. There is no significant difference between the mean. Therefore, between the sample mean and the population mean, alternative hypothesis H1 mu is not equal to 550. As per the given values apply, t-test t equal to 2.31. Therefore, what are the values of t equal to 2.31? The calculator value of t is 2.31 is greater than 2.262. So we reject the null hypothesis at the 5% level of significance. That the average income of the household in the town is not 5,500. Similarly, you can find the other problem also this. The average breaking strength of steel rod is specified to be 18.5 thousand pounds. To test this, sample of 14 rod was tested. The mean and standard deviation were 17.85 and 1.955 respectively. And the result of the experiment is significant with a 95% confidence level. As for the given data, that is the standard deviation is equal to this 1.955, x bar equal 17.85, mu equal 18.5, n equal to 14. 14 is less than 30. The sample is small sample, so we apply t-test. This null hypothesis, alternative hypothesis, degrees of freedom n minus 1, 13. Therefore, 13 degrees of freedom at 5% level values is 2.16. Calculator values is 1.2. Therefore, the calculator values less than the table values mean null hypothesis H0 is accepted at 5% level. Similarly, you can find the all other the remaining problem also you verify and work out. Different mean consider two sample of sizes n1 and n2 take from two different population with the population mean mu1 and mu2 standard deviation sigma 1 and sigma 2. Let x1 and x2 be the sample mean and s1 and s2 be the standard deviation of the sample mean. The formulated null and the alternative hypothesis h0 equal to mu1 mu2 alternative hypothesis h1 equal to mu1 is not equal to mu2. The test statistics is defined as x1 bar minus x2 bar whole divided by sigma 1 square divided by n1 plus sigma 2 square by n2. Just apply for the given data. For this problem, just in two sample of 6 and 5 give the following data. Mean of the first sample 40, mean of the second sample 50, standard deviation of the first sample 8, standard deviation of the second sample 10. Is there is any significant difference between the two mean tested at 5% level of significance? As per the given data, null hypothesis H0 mu1 equal to mu2, there is no significant difference between the two sample mean. H1 mu1 is not equal to mu2. Just apply the test statistics t is defined as values t values equal to 1.85. This the degrees of freedom n1 plus n2 minus 2 equal to 9. Therefore, the 9 degrees of freedom at 5% level is 2.26. Therefore, the calculator values of t is 1.85 less than the table values of t at 5% level. Therefore, H0 is accepted. There is no significant difference between the to sampled means. And the next one, sample of students were drawn from two universities and from the weight is kilogram. The mean and standard deviation are calculated. Test the significance of difference between the mean of two samples. University A, University B, the mean 55, University B 57, standard deviation of University A 10, standard deviation of University B 15, sample size 400 and 100. As per the given data, just apply for the formula. The calculator values of is at 1.265. Therefore, the calculator values of Z 1.26 less than the table value is 1.96. H0 is accepted at 5% level of significance. We conclude that the difference between the mean is not significant. Similarly, you can find the all other problem you work out and try to solve. This summary. Let us recapture the important concept discussed in this unit. A hypothesis is an approximate assumption that a researcher wants to test. It is logical or empirical consequence. It is referred to a professional idea whose merits need to evaluation but having no specific mean. In a hypothesis test, a type 1 error occurs when the null hypothesis is rejected when it is fact true. Null hypothesis is always specific, while alternative hypothesis given the approximate values. That is the last. Finally, you find the keywords.